values, intervals, we'll talk about them, waveforms, and continuous channels. So after you load the data, many people would like to look at the data at a graphical view of the data. To do this, we go to View, 1D Data Viewer window. So it's not very interesting with neurons. So let's add some continuous channels. So we can go to this variables panel and add a couple of continuous channels, which is like analog recordings. So this is what you see. So you can also add waveforms here, but they will be kind of squished because we have a pretty wide window in terms of time. Here you can use these 4 buttons at the toolbar to increase the time range, decrease it, and also to give more space to each of the continuous variables.
Hey, Alex. Yeah, sorry to interrupt you. I have a very basic question. I saw the name of the file is NEX5. So usually after we recorded a file, how can we transfer the format of that file into a readable file of the NeuroExplorer? Usually, for example, for Alpha Omega, after we recorded, the name is dot .map or MPX or something.
Okay, so NeuroExplorer can actually read more than 50, I think, file formats. Let me show you documentation. Yeah, probably we need to start here. So if we go to NeuroExplorer, so if we go to neuroexplorer.com, that's my main site. If you type after com, if you type /docs,
okay,
there is documentation. This is a new documentation. We discussed with Eric that I didn't have it before. It's just brand new. I'm still working on it. The advantage is that you can translate it into Chinese if you want, because it's on the web. You can ask Eric how to do this. I don't have it since my Windows version is English. It doesn't offer me, the Google doesn't offer me translation. So
okay.
if we go to reference, supported file formats. So these are all the file formats that can be loaded. So if you see Alpha Omega, with Alpha Omega you can load like 1, 2, 3, 4, 5, 6 file formats.
Okay. Okay.
And then for convenience, you can keep your files as they were saved by your recording equipment, or you can save them as NEX5. So of course, NeuroExplorer can save only its own data format, and for people with a lot of analog data, it can save in the EDF, so-called European data format, but this is only for continuous data. Okay, so you can scroll, you can here, you can zoom in, like for example, into this event. How I'm doing this, if you click inside this 1D viewer, press Control and then rotate your mouse wheel, this is what happens. You can zoom in and zoom out in time. There are many more options, by the way, in this viewer. To use them, there's no special menu. You right click, and then you see a lot of you can change the scaling, you can change this color scale, etc. But most important is like you can add events. For example, if you have behavioral experiments and you want to and you know that something happened, or you have artifact, you can mark these artifacts here. So I'll probably, if you're interested, I can show you how to do this. Is it interesting, or will we need to go over to some kind of more generic stuff? Okay, so we will not do this, but the main idea is that use right click, then you can see all kinds of options. Okay, so that's how we view the data. Also, while we're here, so at the page when it's called kind of data window, after you open the data file, you can see the properties of the file. You can see all these tabs at the bottom. How long is the file? How many variables of each type? Then you can look at your numeric values. If you want to copy them, you can copy and paste, etc. Intervals, continuous, etc. So, but mostly you work with the variables window. So let's run our first analysis. The list of analysis is here in this upper right corner. It's kind of the way they are sorted is, I would say, in historical way. So as I edit analysis, I just edit them to the bottom of this list. If you have your analysis that you want to use more often, you can always reorder the way the analysis are shown here. Like, for example, if you use this one more often, you can move it here. So let's do some simple analysis. For example, interspike interval histograms. I'll just change some parameter. This is, I played with it. So let me do restore defaults, because this is what you'll see. Or anytime you have some weird display, some weird graphics that you don't like, you can press this button, restore defaults, and then it will kind of be restored back to some meaningful values. So you click on analysis here. If you don't change anything, just simply click OK, and you will see the results. So these are the interspike interval histograms. So you have graphics. You also have numerical results. They are shown if you use this menu command view, numerical results window, or you can use this button on the toolbar. So numerical results, you can also, if you want to save, it's all available here. Again, with right click. And so we'll have for each neuron, we have bin information and the number of interspike intervals within this bin. And on top of that, you have also a little summary table that gives you a lot of kind of overall statistics for each neuron. For example, median ISI, or coefficient of variation, etc. You can also save it as a text file or send it somewhere. So if you want to change the graphics, you can go to the graphics menu, edit graphics. Let's add, let's fill the graphs below the histogram, and use, for example, like gray color. So this is how you change graphics. For me, my laptop screen is kind of small, so if you want to quickly increase the fonts, there is this button, bigger fonts. The way to save these graphical results is you go by using the menus. You go to results, graphical results. You can copy graphics to the clipboard, paste it, and you can save graphics in a number of formats. if you would like to edit the graphs, like I would suggest you save it in a scalable vector graphics file. SVG file, it's a text file. You can now open this file in PowerPoint, for example, ungroup it, and you will have all these elements of the graph available to you. You can change, you can move, you can type different name, etc. But so for quick saving of graphics, you can use send graphics to PowerPoint. It shows the dialog, where you can specify with what PowerPoint file it goes to, what options. You can add a comment. If you click OK, it opens a PowerPoint and adds a slide. So I saved a couple of slides before when I was preparing for the training. So every time you run, you can just simply use this command results graphics send, or simply the simple ways, there is a button on the toolbar, send graphics to PowerPoint. It does the same. So let's play a little bit with parameters. Usually to edit parameters, you can either go back to the analysis panel and click on the analysis type, or if you're using the same analysis, the same results can be achieved by just double clicking inside the graphs. For example, we want to look at the large interspec intervals and use a logarithmic scale. Let's do maximum, say 15 seconds. So now we have logarithmic scale, and we can see that there was some kind of oscillation at around 10 Hertz with 0.9 second interspec interval. Another useful way to save your results is if you want to, so for example, if we close this one now and go to the interspec, for example, open a different file. We will use analysis parameters, the same parameters that we used last time, that we kind of applied this analysis to another file. So if you want to save these parameters to use them later, you can, for example, you can use so-called analysis template. So you go to template, save as new template analysis only, and we can call it like ISI log scale. So now if we apply this one, then let's restore defaults. So we can go to our basic interspec interval histograms. So this is the kind of default way of doing interspec interval histograms. Now if you go to templates and click on it and double click, then it will run an analysis with all the parameters that we saved. So if we can also look, it's kind of we can also look at all the values, because each analysis has around these are all the parameters of this analysis. See, the number of them is 136. So that's a lot, but we can save them in templates. The other thing I wanted to show you, let's talk about how you select variables for analysis. When you open data file, by default it opens all the neurons, and if there are no neurons and there are continuous variables, it will select continuous variables for analysis. And but usually, if you have Windows, that's what you will see. So you have all the neurons are selected. You can either click here at the kind of data type row, and it will select all the variables of this type. For example, let's do neurons and events and calculate interspike interval histogram for all of them. So now we have IIS histograms for neurons and for events. If you want to kind of exclude or include something into analysis, some of your neurons or events, for example, if you want to remove events from analysis, we'll just say select them and press this button showing to the left, from right to the left. Maybe we want to remove this 4. So now we have analysis only for 2 events. The same is, so we also saw that we can now add, apply, and now we have more variables that we analyze. Also, if we double click, there are multiple tabs in this analysis properties dialog. In one of the tabs, you can actually select the variables. Another important tab is selecting data range. You may have a very long recording session, but you want to analyze, for example, I know some people apply a drug to the cell culture, so you want to analyze before and after this drug was applied. So you can specify this in this data selection page. Let's select from 0 to, say, 300 seconds. So it's a little different than we saw, but it's let's use autocorrelograms for this. This is kind of much more interesting. I will remove the events. Then we can also show only neurons in the available tab. So this is these are autocorrelograms. The difference between interspike interval histograms and autocorrelograms is that the interspike interval histogram is a probability of the first spike after the neuron fired, and this is the probability of any spike. So we see this, oscillations of the order of about 10 Hertz. So with high probability of firing after 0.1 second. Let's change the data selection. If we go from 0 to, say, 500, we don't see these oscillations. If we change this, for example, from 800 to 1200, we see the oscillation. So apparently our neurons change properties over time. And one way to explore this is, for example, I know these values, like I know the first 300 seconds, no oscillations, and then around 1,000 seconds, the oscillations are very prominent. How did I find this? I used this Explore panel. Let's just keep it docked. Here we can specify which parameters. So these are the sliders, and we can kind of change parameters on the fly, and then it recalculates immediately. But the interesting part is if we use select data from and to as our sliders, and now we have kind of a sliding window in time from 800 to 1200. So if we move it, we recalculate results immediately, and we can see that there are no oscillations here, and then they suddenly appear when we go to around like 900. So now that, so is it kind of interesting, or I'm going too fast or too slow? Any feedback? Hello?
Yeah. Thank you, Alex. I think it's fine.
Okay. Okay. So let's try to run comparison. So we want to compare, for example, our neuron activity before and after we apply the drug. To do this, we need to use so-called time intervals. So if we go back to the data and select the intervals, and now I will just zoom out. So I created two intervals. One is from 0 to 300, and another is from 1000 to 1300. So in NeuroExplorer, you can specify this time range for analysis with just two numbers, from and to, or you can specify a so-called interval variable. You can actually have multiple intervals. For example, if you have behavioral experiments and you have some events like stimulus, or you work with trials, you stimulate, you want to look at something right after the stimulus. So we'll have multiple intervals. Each interval will start with a stimulus and last, like, for example, 2 seconds for 2 seconds. So here let's double click again, go to data selection. So now we want to use all data, and we can use interval filter from 0 to 300. So that's the one that we saw. Then we can go back and specify a different interval. Yeah, that's another time period with oscillations. We can also specify both of them. To do this, you change this option, interval filter type, single filter. Let's do one multiple filter, one for column of graphs, and then click on filter table, and then see, we have them. Usually you have nothing, so you kind of select both filters, click add, click OK. So now we have 6 neurons, so each row is a neuron, and each column is an interval filter, so like before drug, after drug. Now if we want to overlay this, we double click again, go back to data selection, and click on this option, overlay graphs corresponding to the same channel. So this is what we'll see. So we have a black line is the first interval, and the blue line is the second interval. With are you interested in analysis of continuous variables also? Let me show you. So with the waveforms, we have only one analysis, which is waveform comparison. I was asked to do this for experiments with light stimulation of the brain. So like the researchers wanted to know if the shape of the waveform changes between stimulation and like blue laser stimulation and no stimulation. But here we can look at how well the waveforms are sorted. So you can again here specify the range, you can specify filters. We don't use the filters in this analysis, so we'll just calculate PCA projections. So we can see that, for example, this set of waveforms definitely has two clusters. Another useful feature is so let's repeat some of the analysis. Like for example, we select remove the waveforms, and select all the neurons again, do for example cross correlograms. Here I have not default behavior. So if we this is the standard way. So when we have 6 neurons, cross correlograms will be relative to a single neuron. So we have neuron 05B as a reference. But if we want to calculate all pairwise cross correlograms between this set of neurons, I will double click and here select multiple reference events, and here we can say add all available for analysis, and now you have 36 cross correlograms. Again, if you want to repeat this with another data file, it will probably not work because it's kind of specific set of reference events. But for reproducibility, you can either send these graphics to PowerPoint. So now we have this slide with these cross correlograms, or you can use saved results menu and press quick save results. Nothing happens, but everything is saved in a directory in your documents folder. So now if we go, let's just close this one so we have more room in this bar. If we go to save results folder summary, we can look at the results that we saved. So while preparing for this training, I saved a few interesting results. For example, spectrograms. So the last one we just saved, these cross correlograms. So if I wanted to show spectrograms, I saved the spectrograms here. Now if I double click, it opens the saved graphics with the spectrograms for these 2 neurons, and from here, so this is just saved results. So it's a saved graphics. It's just it's a file. It's just graphics file. With the summary, we have numerical results. We have all numerical results. We have all the parameters. From here, from here we can restore analysis in NeuroExplorer. Let me show you how to do this. So if we close everything, so you open the program and you wanted to restore results that you saved and make them kind of live, like live analysis. Open this one, right click. Go over multiple files or try different conditions, etc., and accumulate numerical results. The way to save numerical results, you go to results numerical, and you can send them to Excel. It's similar to PowerPoint. It asks you for the workbook name, for the name of the tab, where to put the results. You can use, for example, use the topmost empty cell. And so that every time you save results, it will append rows to the worksheet. This is just, you know, an example how it works. You can do the same with MATLAB. You can results, numerical. So you can save them to MATLAB, send them to MATLAB, and then do your kind of post kind of summary analysis in MATLAB. And so we can talk about more about analysis, what they do. So there are many analyses, and there are kind of here they are unstructured. But if you go to the documentation and go to reference, analysis reference, here you can see that I tried to give it some grouping, so I'm not sure why it's taking so long. It will eventually come up. Okay. So we have analysis type, spike train structure. So we have all the histograms. We have some kind of graphs with we have burst analysis. Many people use it. Spectral analysis. We have visualizations. We have dependencies between channels. So different, like we looked at cross correlograms. Perimeter rasters are also interesting in terms of kind of visualization of firing between two neurons. And then we have place cell analysis, head directions, or specific analysis with the behavior. And then we have a number of analysis for continuous data. So at least you have some kind of grouping here. In the future, I will add this grouping in the analysis panel here, so you can kind of say, okay, I want to look at the spike train structure, then you go to structure. You want to visualize, you go to visualization. I only have continuous data as a separate, because sometimes it's confusing what's available in continuous, what analysis are available for continuous data. Another useful option is edit menu. So we can have a lot of things changed in the data file, even so while we analyze. For example, let's open this file, and we can I just want a different file. But anyway, so we can for example do digital filtering of a continuous variable. So the way to do this operations on the data in the file, basically operations mean that you do something with the channels that you have in the file, and it creates another channel. You go to edit, digital filter. So let's do, for example, low pass. Let's remove all this high frequency oscillations. So now we have this variable created. We just created it. It was added to the file, so we can look at them in the 1D viewer. The same idea applies to a long list of operations mostly on neurons and events. If you go to edit, there is this command, operations on data variables. Here you can see a list of, like, you can, for example, you can shift, you can join two spike trains. You can find like synchronous spikes, not synchronous, select trials. You can filter interspike intervals. You can select data only from the interval filter. So let's go back to the start our first data file. For example, if we want to save the spikes of this neuron only for the first 300 seconds, we go to Edit, Operations and Data Variables, specify interval filter. So say first operand is neuron 04A. Now we want to apply filter 0 to 300. Just say N4A 300. And then we press run the operation and then close. So now we have this new event. By default, if you do something with the spike train, it creates a new event. So we can look at what we just have done here in the 1D viewer. So these are all the neurons, and our kind of filtered channel is only from 0 to 300. Another useful, extremely powerful option is scripting. So I'm writing scripts all the time, and I'm doing this for customers. Some people need a special processing, so you can look at how many scripts I have here. To start with scripting,
Sorry,
let's.
Alex, can I have
Yes.
a question here? You mean the scripts that here you wrote and that customers can use it, right? It's already.
Yes.
And can we also write the scripts by ourselves?
Yes, of course. Yes, that's the idea. So I spend a lot of time integrating Python into NeuroExplorer. So scripting can be done in Python. So first I had my own scripting language, which is kind of very limited, but now Python is a very popular language, and you can find a lot of information about it.
You mean Python, right? Right?
Python, yeah, Python.
Okay.
So if you go
that we could directly use Python, MATLAB, or other computer language and directly import it to script also?
Yes, no, it's kind of so with Python, when you install NeuroExplorer, it installs its own kind of internal distribution of Python, which is both 2 and 3, because I started with 2, now I have also 3, version 3 if you are familiar with Python, and it installs NumPy. So if you are happy with just basic Python plus a few toolkits, like NumPy is kind of the main one, then you can simply write inside NeuroExplorer. But you can also just use basically NeuroExplorer provides a set of functions. So you can start Python in any development environment. Let me just show you in the help file here what happens. If you go to scripting reference, introduction to scripting. So we have this editor. I'll show it in a second. So we have all these functions available in NeuroExplorer, and this is just a regular Python script with open and CSV, but it uses some of the functions that start with next are the functions that I implemented that talk to NeuroExplorer. And also, you can use external development environment. It's all described here. So basically what happens is that NeuroExplorer will start a TCP server, and your program will talk to NeuroExplorer via TCP, but you will not have to look even, it will be exactly the same script, but now you can run it anywhere. So for example, this is, I'm running Visual Studio Code, and I have a script that you only need to add 3 lines. And after this, you just, use your Python, and then you can use your NumPy, and then you can use your next functions that I implemented, like select file, etc., etc. So this is very, very powerful and flexible.
Okay.
So if you need help with scripting, just send me an email. I'll be glad to help.
Okay.
I love Python. I'm doing a lot of things in Python now.
Yes,
Especially like all the documentation is Python based, etc.
It's wonderful.
Okay, so let's start with a very, very simple way of starting with scripting, which is record macro. But first I would like to make sure that I have Python 3. I go to script, Python options, 3.7. Because the problem is that, I try to keep it as 2.7, because if customers have older Python scripts, they suddenly do not work. But I'll do a check in the next release of NeuroExplorer. I will check if there are no Python scripts by a customer. I'll just switch to 3.7 by default. So with recording macro, for example, if we want to run like this, interspark interval histogram, this simple analysis for every file in our folder. This is how you do this and how you start with scripting. So we will not save changes, and then we press record macro. Macro name repeat ISI2, save as a function with data file name. Okay. So now, since it says stop, it means that it's now recording all my actions. So I open the file, I run the analysis, I save results to PowerPoint, and then I close the file, and then I stop macro. So here we see NeuroExplorer open the script editor. This is the macro. These are the steps that we we executed. And this is another function that just lists the files with known extensions. And here instructions: if you uncomment the following lines, specify your own data directory and file extensions, then you can run this macro on all the files in your directory. I already did all these changes, so let me open the file that I prepared. It's just the same thing as here, except for I did all this uncomment. By the way, to uncomment, you select the lines and right click, so you can say uncomment here. Okay, so let me open the file that I did before the training. So again, we have all these steps: open document, select neurons, apply template, send graphics, close. The uncomment, I specified the data directory. That's this one. That's, by the way, that all the NeuroExplorer files will be in C users, your username, documents, NeuroExplorer 5. And file extensions we want, next and next 5. Then for file path in this list returned by this list files function, we will print print the file path and execute macro. Let me see. He opens the file, runs analysis. Oops. Line 15. It doesn't have. Yeah, I added this line. Didn't check this script. Sorry about that. So we need to close open document. So open document is in next. Get active document. Let's close everything. So it opens each file in the folder, runs analysis, and saves results to the PowerPoint. So these are the three, the results that we just saved. So this is how you start developing scripts. But as I said, it's very powerful, and I encourage you, if you need something special, just use it. One customer sent me a script with so convoluted logic. I was kind of trying to debug it for the last day and a half, but I'm here to help.
Okay.
Okay. So
sorry,
this...
Alex. Maybe I have one requirement. Maybe it's I'm not it's rational, but for example, sometimes our end users need to how to say perform some functions, but they don't know how to script. They can give description. Can you do some favor? I'm not sure frequently, but for example, some special functions need to perform. Can you help to do to give us a script? Then they can do the analysis.
Yeah, sure. Yes. I worked with several customers that just wanted very specific script. They had a paper. We went back and forth, like some fancy burst analysis when one professor in Germany with some guys in Howard Hughes Institute here in the States, they wanted to like load new data file format. I wrote the script for them. Yeah, so I'll be glad to help you and provide you with the script. I actually even developed a way to send those scripts to the customers. So if you go to help, and then download support files.
Yes.
So all you need is a number. So I will zip all the scripts and templates and other files that customer needs, upload them to my website, and provide you just with the number. So you just specify the number, and NeuroExplorer will download all the files, unzip them, put the template file into templates directory, put the script file into scripts directory, and even execute the script. So this is a kind of I'll be happy to help you with any kind of analysis if it's not something that's kind of 50 pages script or like a huge project, but anything, any customization, any small analysis, anything with import export, I'll be glad to help you with.
Thank you, wonderful. Thank you.
Okay, so I'm almost done. So any more questions or suggestions or any other things about the program?
Yeah, guys, do you have any question for Alex, or you want to learn something more, or you?
No question from my side. Thank you so much for Alex to introducing such strong tool to us. Thank you for your time.
You're welcome. Thank you. Okay, so yeah, of course, I mean, there are so many things you can do, and I cannot even even start with this, but I also have some training slides that are maybe obsolete by now, but I may kind of send you the PowerPoint presentation with kind of simple to advanced step by step. But I think the main thing I'm trying to do is I'm trying to add more tutorials to documentation, because now it's web-based, it can be translated into any language. So some customers ask me, or the companies that sell NeuroExplorer ask me, do I have videos? I'm not sure if video is the best for the people kind of outside Western Europe and America, because if I talk fast in English, may be difficult to understand. They have to stop, but of course they can get. I mean, videos are also useful when you can explain a thing, a little kind of feature, within, like, 1 minute, 1, 2, 3, 4, and there's the result. But so far I'm spending time on tutorials that will be web-based, so you can translate them into any language.
Yeah. I think that's very good, and I will share to our colleague and users about totally how to reach that user. Yeah, they can read in Chinese. Yeah.
Yes. Yeah, and yeah, it's all kind of work in progress, but should be my new version with all this, will be new PDF file with all these tutorials and new help also and also the other nice feature of this online help is that there is a real good search. So you can search for anything. And because people ask me, do you have tutorials? Do you have like what analysis should they use? But at least now I grouped analysis in kind of, folders. This is for structure, this is for dependencies, this is for spectral. So people can kind of, will be a little easier to use.
Okay.
But yeah, but feel free to contact me. When I started,
Yes.
I was kind of traveling, I was seeing customers, I was going to neuroscience, but now I'm almost like Microsoft. Nobody asks me questions or ask for new features.
Yeah.
So I'm open to suggestions.
Yeah.
But
do you think there is possible to come to China to do some workshop?
Yes, of course, I'll be glad to. If you pay for my travel expenses, I'll be glad to come.
Yeah. I think, for example, after the COVID-19, come down, maybe we will hold some workshop on site, so we can discuss.
Yes, of course. No, I'll be glad to come. Yes, I'm curious about China. I've never been to Southeast Asia, and it's all kind of mystery and interesting place to be. Yeah, but of course now travel. My wife went to Russia a couple of days ago. Oh, she spent like 2 days filling the forms, and she took the test, and like even to transfer in London, you have to load the app, you have to provide test results, and it's like, just. But then she told me that after all this work at the airport, nobody asked her about test results. In Russia, nobody asked her about test results. So it was all just paperwork. So they have this in their system, and that's it.
I see. Okay, Alex, last 2 questions maybe. And the one is that the alpha omega systems can do closed loop. For example, they can do record, can do also stimulation. And do you think NeuroExplorer can send some, like, can communicate with the system online? For example, it can send some a script to our system to do stimulation. Do you think that's possible?
Yes, it's possible. Currently, actually, if we go to, let me just share the screen for a second again.
Yes.
If you go here, online, there is online menu.
Okay.
And there is AlphaMap. You can connect to AlphaMap server, and I'm not sure if it's up to date, but the idea is that you can connect to AlphaMap server and receive data while you are recording, while you are doing your experiment, and analyze it. During,
okay. I got you. Maybe we can try that function for the connection to the
Yes, so but maybe I need to talk to engineers to make sure that I have the latest protocol, and because it's been done like a few years ago, so I'm sure stuff can may have changed, and I need a test program so I can kind of debug it here at home.
Yes, I see. Also, we R&D is developing a new platform. It means that include hardware and software, and maybe in the future we will try to that compatible with NeuroExplorer to to send data or to get data from NeuroExplorer.
Okay, it's not as kind of if you have requirement for really precise time, it's hard to do, because what I do is I have a loop, so maybe 50 milliseconds, so it'll be delayed. It's not something that kind of immediate, because I'm talking to the server, I need to analyze the data. So, but we can start this conversation. So what do you need? Well, strategically, what do you think will be useful? So we can work on that.
Oh, sure, I hear you. And the last question is that I saw you show lots of analysis tools, right? There are at least maybe more than around 30 analysis ways. Do you have some documentation to explain or to describe every analysis, what scenario it may use, or what is the main purpose of that analysis? Because for some initial how to say, some initial student, maybe they would like to know that when they choose which analysis to do analyze.
Yeah, so it's in my documentation, in the analysis reference, it tells you like in a couple of sentences what this analysis does, and then it explains the algorithm. So for every analysis I have an algorithm, but I think what's missing is so maybe I can add to my documentation something with the picture. So this is your data, this is what this analysis does, and this is the result that you see. But I can tell you, I just talked to a customer who was just started using the program. He basically went himself through all the analysis, and but yeah, he's kind of very experienced. He's not a student, of course. He's like a senior researcher. So he said, okay, I know this, I know that, how to use this. But for a student, it's maybe it's kind of every laboratory has its own requirements. So, but I can start at least with the pictures. You see, okay, this is the output you get. This is what it does, and then maybe if I can find a reference to a paper. But I don't know if do you think it's useful? Would be useful?
Yes, I think so. If we have the documents that can list all the analysis functions here and give some very simple words, for example, when and how this help them to do analysis. Means what's the scenario they will use, which analysis, that will be helpful.
Yeah. Okay. Yeah, and what scenario? Yeah, that sounds good. Yes, it's a good suggestion.
Okay. That's all. Thank you so much, Alex. I think yeah. So use your time. That's the not work time. Thank you so much.
It's okay. It's getting dark here. How is the weather in China? Is it hot?
It's good. It's somehow it's good. Yeah. Thank you. If
okay, you're welcome.
Yes. Maybe you
Alex.
Connect you again by email or by others to ask more questions.
Okay, sounds good. Thank you. And yeah, any feedback on the actual tutorial, what I missed, what I should include, but maybe if all